G'day Year 9s. I just thought I'd make a couple of videos to make it a little bit easier for some of you trying to see all of the work we're going to get done today. We're going to start off with exercise 9F, experimental probability. And this is going to be fairly straightforward for most of us. Basically, sometimes we're able to calculate theoretical probabilities, like when we're rolling a die or something, and other times we need to use past experience to estimate probabilities of future events, like if I owned a store and sold soft drinks, and I could use the number of sales of each different type of soft drink to help me predict how many I'll sell in the future, so I know what to order. That's an example of where this sort of thing might be useful. Two things we need to know, two rules out of this, that are fairly common sense, which is good to know. First one, experimental probability is just another way of saying the relative frequency that we've been doing in statistics in previous years. So an experimental probability, you look at the number of favourable outcomes, or this time they've said the number of times the outcome occurs, and you divide it by the total number of trials. So if I was selling soft drinks again, I might look at over the week I sold 1,000 soft drinks and 400 of them were Pepsi Max. Then I would know roughly 400 out of the 1,000 drinks I sell would be Pepsi Max, which would be a probability of 0.4 or 4 over 10 or 2 over 5, however you want to write it. All the same thing. The expected number of occurrences, so this would be useful if I was now ordering the number of drinks for a month's time, and I know that the probability of Pepsi Max is 0.4, and I'm going to order for 4 weeks. I might order 4,000. Then the total number of Pepsi Max I'd need to order would be 0.4 times 4,000. We'll look at some examples where I actually write on the screen rather than just say it at you there. But the expected number of outcomes, you just take the probability and multiply it by the number of times you're going to do that trial. Let's look at this first example. A box contains an unknown number of coloured balls, and a ball is drawn from the box and then replaced. The procedure is repeated 100 times, and the colour of the ball drawn is recorded each time. 25 red balls were recorded. Find the experimental probability for selecting a red ball. Well, we got 25 red balls. We did this 100 times, so the experimental probability of getting a red ball is approximately equal to 25 out of 100, or just a quarter, or 0.25. I probably stick with fractions, but it's okay for those ones if you don't. Find the expected number of red balls drawn if the box contained 500 in total. So I think what they're saying is if I drew red balls 500 times, the expected number of red from 500 trials is 1/4 multiplied by 500, which would be 125. I think that's the question they were trying to ask. If the box contained 500 and we still only had 25, then it would be a probability would be less. That was not well worded. There's one here for you to try. I'm going to pause the video. Oh, in fact, you should pause the video because me pausing the recording won't help you. Pause the video now, have a go at it, and then you can check back and see how you went. Alright, so let's compare your effort with mine. A biscuit jar contains an unknown number of biscuits, and a biscuit is drawn from the jar, then replaced. Repeated 50 times, that's touching a lot of biscuits, so let's hope they were individually wrapped. And the type of biscuit drawn is recorded each time. 30 Choc chip biscuits were recorded. Find the experimental probability of drawing a Choc chip biscuit. So the probability of a Choc chip biscuit. Get my pen working there. That does say biscuit almost. It was 30 out of 50. Or 3/5. The expected number of Choc chips out of 200 Choc chip biscuits, but just for brevity, I don't want to have you watching me draw slowly all the time. Expected number, 3/5 of the 200, which is going to work out to be about 120. So we've got the probability of a Choc chip biscuit about 3/5, and the expected number had 200 biscuits in the jar, I'd expect there to be about 120. Did I say 2/5? I hope I said 3/5. That's it for this exercise. Pretty straightforward. Relative frequency, how many favourable outcomes divided by the total number of outcomes. That's your estimate of the probability or your experimental probability. And to find the expected number in the future, just take the probability and multiply it by the number of trials. Nice and short video there. I hope you enjoyed that. Get stuck into the questions that are recommended there. You'll see them. They won't take you very long. And then you'll be on to the next exercise. Keep up your great work, guys. Bye for now.